Hello everyone and welcome to this afternoon's webinar. The title of the webinar is Test Your SQL and PL SQL, Not Your Patients, and this webinar is being presented by Jacek. This webinar is part of a collection of webinars which have been brought to you by the OUG Ireland Committee. I just want to say thank you for taking the time to attend, and I hope you'll find this session useful. My name is Alexandra Moore and I work for the UK OUG to deliver events and webinars such as this one. Before we get started, I just wanted to cover a few housekeeping things for this session. Firstly, if you have any questions throughout the webinar, please do type them into the chat box, which you can find on the Zoom control panel at the bottom of your screen. These questions I will put forward at the end of the session. Alternatively, if you would like to be unmuted to ask your question in person, you can raise your hand. The option to find this can be found on the participants panel, which is also on your Zoom toolbar. All questions will be asked at the end of the session, so please go ahead and ask anything that you need to. If at any point during a session you're unable to hear me, Jacek, or see the presentation, please also type this in the chat box. I'll be here all session and we'll be monitoring that. I'll try my best to resolve any issues that you have there. Today's webinar is being recorded and a link to the recording will be sent in a post-webinar email along with a copy of the slides. I just wanted to say a little bit about what the UK Oracle User Group do to support you and your community. We deliver content through webinars, virtual roundtables, events and conferences relating to all Oracle applications and technologies. Whether it's a problem with said technology, the latest updates, or to make better informed decisions about your journey, we can help. Being independent from Oracle means we deliver unbiased content and provide honest solutions to your problems. The majority of our virtual, I've gone a slide too far there. The majority of our virtual events are recorded and stored in our online library for members to access at any time. This includes the other presentations that have been part of this series. Coming up in the series still, we've got Game of Fraud taking place tomorrow, which is being delivered by Abby Giles-Hay and Chris Saxon. And then next month, we've got Sharing Experience from 24 months of database upgrade and migration. You can find details of those online on our website. And so now, without any further ado, I'm going to hand over to our speaker, Jacek. If you'd like to share your screen for me now, you can go ahead.
Hi everyone, my name is Jacek Gebal, and as mentioned by Alexandra, the topic for today is Test Your SQL and PL SQL, Not Your Patients. So maybe I'll start with a few words about me. I'm a software engineer since early 2000, mainly focused on Oracle databases. And I worked on multiple projects across the years, but in 2013, when working for Pragmatists, I got infected with agile methodologies, testing, automation, and I stayed like that ever since. I became a key contributor and author of utPLSQL version 3. It was 4 years ago, and I'm still active developer and testing advocate. You can reach me on Twitter or email, and I have a blog, though it's not really very active. I always think about going back to blogging, but the everyday life makes it so that it's really difficult for me to find time to do that. Right, so what's the plan for today? I'll be talking about why, what, when, and how we should be testing. And I think those 4 questions are essential if we think about software testing, because we very often tend to just do the testing or just don't do the testing without asking those questions. So let me just start with why testing is important. And according to Applied Software Measurement, a book published in 1996, was many years ago. Even then, before Agile was born, they noticed that majority of the bugs are introduced in the coding phase, and most of the time where they are found is in the late testing phase. And there is another very interesting layer on top of that, which is the cost of bug fix. And as you can see, the longer or the further away from the coding, the more expensive it is to do a bug fix, and it grows almost exponentially when it hits production. So when we think about testing, it's in essence, it's cheaper to prevent the bugs than fix the bugs. So the testing phase should be as close to coding as possible. And some of the bugs are really funny or non-harmful. You can see the stack trace here on the receipt. Or they can be disastrous, like rocket catastrophe. And in essence, testing is much cheaper and safer than bugs. And if you just do Googling, you'll find multiple examples of software failures that costed millions or costed a company reputation or put people in jail or killed people. So software nowadays is everywhere, and proper testing is essential for making our lives safer and more safer. That's looking from like usability perspective on the testing side. But when you think about yourself as an engineer, if you are engineers in this session, there are engineers in this session. So what does it really give to an engineer when he writes a test? So when you write a test, you make your newly written code changeable because you have test that confirms that that the code is doing what it should be doing, so that you and the others can safely change the code and have that safety harness of a test to validate that the code is working as it should. You can also prove that the solution that you've provided, so the software that you've written, meets the business requirements. So the test should represent the business requirements, and therefore, when the test is passing, it means that the software works as expected. Additionally, if we're talking about change management, you want to make sure that the change that you introduced in the existing software didn't break existing functionality. And that's why having a portfolio of tests allows you to build that confidence that if all of the tests are passing, nothing is broken. And finally, your tests can become a living documentation of the requirements. So they can document the requirements of the system and reveal the intention of the code. So when you're looking at some piece of software, some procedure, you might be wondering what it's actually doing, why it's doing what it should be doing. And if your tests are transparent and easy to read, then the tests could reveal the intention. They can tell an engineer why the software works the way it works or what it's actually doing. And one important note, everyone nowadays is talking about continuous delivery, automation, time to market. DevOps is the new buzzword, continuous integration. When you're not writing automated tests, you cannot talk about doing DevOps. DevOps is not about just deploying software to production. And so neither is continuous integration, because continuous integration is all about integrating the software and making sure that it works together. So how do you make sure that it works together if you don't have an automated suite of tests? And how can you deploy continuously to production with confidence if your software is not tested automatically? So your software testing should be part of your DevOps and should be part of your continuous integration, so that each time you do a change to your software, you run your tests as part of the continuous integration or your automation, and then those tests prove or validate if the software is working correctly. So that was it when it comes to why. But we might think, okay, so I know why I should be testing, but what is the scope of the tests? What should be tested? And I'll be focused now on the database world because this is a database talk and I'm talking about database testing framework. So when we think about the database, what should you be testing in the database? And in essence, when you want to a one-word answer, it's all the logic. So all the logic in your database, whether it's PLSQL logic or whether it's SQL queries, constraints, data types, views, and calculated columns, all of those represent some form of logic in your database. And you might also want to validate the input and output of queries in your database or inputs to your stored procedures. And definitely what you're interested in looking at exceptions and corner cases, not just looking at the happy path. There is also a concept of data quality and integrity, which is more focused on the state of the database, which is just to prove that the data in your database is in good shape. It's kind of different to testing software because software is about testing the behavior, whereas data quality and integrity is more about testing the data itself. So even though it exists, I won't be looking at it today because we're talking about testing the software itself. Right, so when should I be testing? In essence, again, whenever you make a change to your code or data structures. So each change that you do should be tested. And by tested I mean either by running the existing tests or by adding new tests. So if you're doing a change or creating a new behavior in your software, you want to write a new test. But if you're changing the existing behavior, you would expect some of the existing tests to break, and you probably would need to change those tests because the behavior or the expected behavior has changed. So in essence, you should be testing early, testing often, and continuously and automatically. And remember that the later you test, the harder it gets. So if you're writing a small piece of software, it's easier to test after, let's say, half an hour or 2 hours of work than it is after spending 3 or 4 weeks building big solution. Because when you spend 2 or 3 weeks building a big solution, then you might spend another 3 weeks writing tests for it. And by the time you finish, you probably won't remember where you started and you're getting lost in all of the requirements and what else the software that you have built actually does. That's why you should be testing frequently. So I'll touch base on one technique that's really useful when it comes to testing. It's called test-driven development. And it divides the software delivery process or your process of daily activities into 3 small phases. There is the red phase, the green phase, and the clean phase. And then you go and repeat. So in the red phase, you start by writing a failing test. And the test should be a simple example use case of your code. And then because it's an example or a use case for your code, then it becomes the documentation. So it says like, this is how the code should behave. And the test is red, which means it's failing because you write the test first. So you start by writing a test without writing functionality. Then you go to the green phase. And in the green phase, you write only enough code for the test to pass. You try to get to this successful test as fast as possible without thinking about how the code should be structured, what the variable names should be. You try to solve the technical problem without solving the design. In the clean phase, however, you're improving the structure. So you might think, oh, maybe that should be a global variable or a constant that should be named differently. Maybe there should be function, not a procedure, or I should maybe format the code differently, remove some duplication. All of that is happening in the clean phase. But in the clean phase, after each cleanup, you run the tests and you make sure they stay green. So by this, you're dividing your coding into 3 separate challenges, so to say. First, you define what is it that it should be doing, and this is the test. So your test defines what the code should be doing. Then you figure out, okay, so how do I write the code to satisfy that test? And then you think about what it should look like, so the structure, the design. And because you're doing it in small steps, it's actually pretty simple and allows you to focus on one problem at a time rather than trying to combine all of that into a blob of thinking about 3 different aspects of software engineering in one go. So it's a really nice divide if you want to avoid struggles when delivering solutions. When we talk about testing, there is a really nice set of principles for testing. They say it's principles for unit testing, but I think it's applicable to any testing. They call them first principles. And the first principles say that test needs to be fast, because if your tests take 20 minutes to run, how many times during the day will you run them? Maybe you will run them just once. So that means you accumulate a day of work before you run your tests. If it takes 5 minutes, that's 5 minutes of waiting. So you probably will get distracted and start doing something else. So the faster your tests can run, the better, because you're more likely to execute them more often and you won't get blocked or slowed down by the test execution time. Tests should be isolated, and that's a very important principle, meaning like one test should be one use case and the test should not depend on other tests. In that way, your test is an individual unit. You can run it by itself or you can run it alongside other tests, and there should be no dependency between the tests. So when one test fails, it fails for the reason that either something is wrong with this test or there is something wrong with the code, not because some other test failed or some other test was changed. Tests should be repeatable, meaning that whenever you write a test and you run it, if it is passing, it should be passing consistently unless the code is broken. If it is failing, it should fail consistently unless the code is fixed. So you don't want a situation where your tests are usually passing, but let's say Friday evening they fail because something happens on Friday evenings, or they shouldn't be depending on things that are not related to your software. You want your tests to be reliable. They should be self-verifying, so I mean obvious, so that when you read your test, it is obvious what the test is testing and what should be the expected outcome. And writing obvious tests isn't easy. So the smaller the test code is, the easier it is to understand what the test is testing. And the tests should be thorough and timely. Thorough meaning they should test or cover as much of your code as possible, and timely, written in time. You don't want to write your tests 6 months down the line when you've written the code, because that's way too late. For 6 months you don't know if your software was working properly or not. Right, so what kind of software tools do we have available when it comes to PLSQL and SQL? Well, the 2 big players is Quest Code Tester and Oracle SQL Developer. They have their own, like Quest has its own testing solution. SQL Developer has a built-in unit testing UI as well. But those are vendor specific, meaning like if you go with Oracle SQL Developer, you need to use Oracle SQL Developer and that's it. With Quest Code Tester, you actually need to pay for it. There is utPLSQL version 3, which we created a couple of years ago, and it's still being maintained and new functionality getting added. And there are multiple other testing frameworks, if you would like to choose from, available on the market. Now, the good thing about utPLSQL is that it's PLSQL. So maybe let's just go here. Why utPLSQL is good? Because it's free, it's open source, and it's IDE independent. So you can run it whether you use SQL Plus or you use Toad or you use SQL Developer. Whatever IDE you use, you can run utPLSQL tests. It's self-tested, so we have unit tests for the unit testing framework. It's still actively developed and maintained, compatible with Oracle 11G release 2 and above, including the latest releases of Oracle databases. It's pure PLSQL, so all you need to do is learn and use PLSQL to test your PLSQL. It allows for easy cursor and object comparison, has code coverage reporting, which I'll talk about a little bit more, and has automatic transaction control, which is a really cool feature. And it's very easy to version control your tests because your tests are just packages as your regular PLSQL packages. So you can version control your test code along with your source code and deploy it to different databases as you need. And also utPLSQL has a unique feature, which is the data type aware comparison. So when you compare, let's say, number 1 to varchar 1, it's not the same. So it actually can detect whether you're comparing the same data types or not. So how do you go about writing utPLSQL tests? Well, as I mentioned, the test packages are regular packages, but they use annotations. So it's --% suite. That annotation says, well, this package is a test suite. And you can provide an optional description here, what the test suite is about. And then each test procedure is annotated with --% test. And you can provide the description of the test in the brackets as well. Then in the package body, we use expectations to assert on the data. So in your test body, you specify utExpect your actual value to equal the expected value. And there are multiple different expectations and comparators that you can use. You don't need to use equal. There are multiple others to choose from. And then finally, when you create a test, you can run it by invoking, exec.ut.run, and then you provide the package name or the schema name. There are multiple parameters for ut.run. And that's pure PLSQL, so you can run it from SQL Plus or any other IDE that connects to Oracle database. Right, so that's it when it comes to theory. I'll go with an example of how you can actually go and do test-driven development in Oracle database. And I'll start with a very simple use case because we don't have like hours of time to go through more complex things. And this simple use case actually demonstrates how you can do test-driven development for PLSQL. So I got a requirement from the business that they want to have a new function in the database, and that function should be creating rooms. Well, actually creating one room. So if I pass in a room name, it returns a room ID and creates that room. And it throws an exception when the room name is null, and also throws an exception when the room already exists. So let me go quickly to command line and let me show you step by step how you could go about implementing tests and implementing code for this requirement. So I'm connecting to my local database, and I'm checking what version of utPLSQL I'm using. So to do that, I'm just doing select ut.version from dual, and you can see I'm using version 3.1.11 development, which is like not official release. It's the latest and greatest that we're still actively developing. So I'll start with creating an empty test package, right? And that is just a package with a suite annotation, nothing more. There is not a single procedure in it. And when I run it by invoking ut.run, and I'm also passing information that I want to have color output, you can see it actually called that package, and the suite name is visible in the description. It says 0 tests. Well, of course, there are 0 tests. There is no test procedure here. So I'll go and add a test procedure. You can see there is a test procedure, and the test name or description that I provided is exactly as the requirement. So I say the function create room creates a room with a given name and returns its ID. And then there is this test that I should implement. Now, if I try to run it, this fails, but it fails gracefully, saying that this test failed because there is no package body. I just created this test package specification. So I'll go ahead and
Hello there. It looks like we might have lost Jacek for a moment. Not sure entirely where he's gone to. I can still see him online, so hopefully he will reappear in a moment. I'm afraid I'm not quite as knowledgeable as on the topic as him, so I wouldn't be able to fill in for him, but I'll just give him a moment or two. Are you still with us,
hey,
Jacek? Ah, there you are.
sorry, I got disconnected and logged back in. I hope you can hear me okay. If my voice is breaking at any time, Alexandra, just let me know. It seems like my internet isn't as stable as it should be.
Oh dear.
I hope everything was.
We can hear
I
you
hope it
again now.
will be. Yeah, let's give it a try. And if I'm breaking up, let me know.
Will do. Thank you.
Okay. So I'll go ahead and define the test body. So in this case, I'm implementing the package body for the create new room function test. So as I said in the requirement, I want to have a function that will create a room. It will accept a room name that is a string or a varchar, and it will return room ID as integer. And the package is compiled with errors, and this is, of course, with errors because the function doesn't yet exist. Now, the interesting part of this is, however, that I have created a specification of what the function should be like in my test. So this test is already specifying that the function should be named create room. It should have a room name as a parameter, and it should return some integer value. So let me just fix that by creating an empty function. That's just a skeleton that will satisfy the requirements of the test. So now when I run my test, the test passes, even though it didn't test anything. So you see, well, the test compiles, the function exists, the function is doing nothing, the test is passing. So I'll actually implement proper tests now. So in my act phase in the test, I'm calling the function and then also checking that I can select a name into room name variable from the rooms table, where room key equals room ID that was returned by the create room function. So what I'm really verifying is that the create room function call actually saved that room name into the rooms table. And then in the assert phase, I'm verifying that the room name is the same that I passed in here. Right, and you can see the package was created with compilation errors, and this is because there is no rooms table yet. So when I run the test, it fails because the test body has errors. So I'll fix that by creating the table rooms with the proper columns, a primary key constraint, and the room key is auto-generated. Now when I run the test is failing again, but with a different error. It says no data found. And if you remember, the function that I created was just an empty skeleton. It was doing nothing. So let me fix that. I'll implement the function to actually insert the data. So I'm inserting the data in this function, and I'm returning the room key into the result, and then I'm returning the result. So when I run my test now, the test is actually passing. Yay! So I actually I have test-driven creation of a function and a table. And the test is passing after that. So I've implemented the functionality of the first requirement, creates a room with a given name and returns its ID. So let's go ahead and try the other one. We say that it should throw an exception when the room name is null. And in this case, my test will be very simple. I just use the throws annotation. So what it actually means is that when this test is executed, this test should throw this exception. And when it throws this exception, everything is good. If it doesn't throw this exception, then there is a problem. So the test will fail if there is no exception. And I'm implementing the test in a very simple way. I'm just calling my function with a null value as the argument. And it should fail because it is expected to throw an exception. And we can see that the test is actually failing because we expected an exception, but nothing was raised. So the function succeeded. It didn't throw any exception. We actually allowed a null room to be inserted. So let's fix that. And I'll fix it by changing the table structure. So I'm adding a constraint saying that name is not null into my table. Now, when I run my tests again, you see that it actually, both of the tests are passing now. So I have two successfully implemented behaviors. And I'll just go on quickly to the third one, which is throws exception when the room already exists. So it should fail on duplicate room name. And again, the implementation is quite simple. I'm just creating the same room twice in single test. So when I run my test, this doesn't throw any exception. And I expected the -1 exception to be thrown. So let me fix that by adding a table constraint saying that room name must be unique. So when I run my tests now, everything is good. All three requirements have been met. That's it for the demo. As you can see, within a few minutes, of course, using a script, I was able to demonstrate test-driven development in PLSQL using utPLSQL. So what did we get really by doing test-driven development in this case? First of all, I got a really fast feedback loop because I had the test written already before I started coding. So each time I added a piece of code, I could already test to see if everything is working as expected, rather than writing the code blindly and then checking if it actually works. And I didn't spend much time doing manual tests. I really didn't spend any time doing manual tests, like invoking that function from SQL Developer manually, because everything was tested through automation. The good thing is also that the test was tested for both failure and pass. So I know that the test will fail if the code doesn't work, and the test will pass if the code works. It is quite important because it's easy to write tests that will always pass if you don't test them for failure. Tests were created from requirements, so they actually represent requirements. The code was created to satisfy the tests. And again, I saw progress and I got satisfaction with every single test because I saw that I made some progress with every single test. And I can safely now change my code because it's covered with tests. One interesting thing that some of you might have noticed when I was doing the demo is that I was running those tests over and over again without doing any rollback, but my tests were not failing on consecutive runs. And this is because utPLSQL has automatic transaction control, and it maintains test isolation automatically. So it means that each test is isolated because we create a save point in a transaction before the test. Then we run the test, and then we roll back to the save point from before the test, which means that when the test finishes, all of the changes done by the test and the tested code are automatically rolled back to the point in time before the test. So you can have multiple tests in a suite, and then that suite is also isolated so that a save point is created before the suite, and rollback to save point is executed after the suite. And this works only if your code doesn't use transaction control, so you don't issue rollback or commit in your tests, in your code or in your tests. And this functionality can be disabled with rollback manual. So I created just one test suite, but in real life scenarios, you won't be dealing just with one test. You probably will be creating hundreds of tests or thousands of tests for your project. And you need a way to organize your tests. So the first unit of organizing the test is the suite. So you create a test package, and that's a test suite. And you can see in the test results report that all of the tests that belong to a single suite are aggregated under the suite name. But you can also use suite hierarchy, so you can nest the tests in a suite path to organize your tests as you would organize your files in a folder structure. And this is done by the suite path annotation. So imagine we have two test packages, add room content, remove room content, and they both belong to the same suite path, or utPLSQL demo test rooms. Now I can create a test rooms package, which actually is like a parent folder for those two test packages, because you see they belong to the same parent suite path, and those two packages are actually within test rooms package. By doing that, we're saying that the test rooms, those two packages are actually within that test package. And the other interesting part is that you can actually share common setup, which means if you want to set up some data for multiple test packages, that setup will be visible throughout the duration of the whole test rooms suite. So that includes these two suites as well. Another way of doing that is through using contexts. So you can also do exactly the same grouping of tests using context annotation. So you can have a single test suite with context inside saying that this is test rooms package that has that tests the rooms functionality. It has a shared global setup for all the contexts, and there are two contexts for testing the add room content functionality and for testing the remove room by name functionality. So choose your flavor. You can do it in multiple ways. Contexts can also be nested. One thing that I have noticed, however, practically is that contexts, if you have many of them in your test suite package specification, it actually makes things harder to read if there is many of those. So probably better to have smaller units, smaller suites, and maybe more of those test packages. So when you think about organizing your tests, you can nest suites, and that suites can be nested if one within another. You can do the same with contexts. You can group the suites under common parent, and you can also invoke tests on a suite path by calling ut.run with suite path as an argument. And setup is visible across children of a common parent. Right, I know we're short on time, so I'll just move on with the presentation, and Alexandra, if you could just let me know whenever I should break, then I'll do that.
I will do, thanks.
Okay, so I mentioned code coverage, and when you think about code coverage, it's like a coverage map that indicates how well the area of your code is covered with tests. What does it really mean is it's a measure that describes actually if your code was executed within a particular test run. So it doesn't really say that the code was tested. It actually says that the code was executed. It's a very important management and message for the management, really, because when you think that code coverage is important, I think it's valuable information to have visibility into code coverage, but it's more important to have confidence in your tests. So trust your tests. Know that your tests give you value, regardless whether they cover 50% of your functionality or 30, because you might have 100% code coverage and zero confidence in your tests. Then this code coverage is just a throwaway. So what does it really mean? Like how utPLSQL does code coverage? We leverage DBMS profiler to get the line coverage. And when you look at this simple function, we have 3 executable lines: the if statement, the return, and the return. The rest is just non-executable structural code. And we can write 2 test cases to get 100% coverage for the A is null and A is not null. Now, you can write the same code in a different way, right? You could just write it in a single line. And in that case, when you think about line coverage, that's one line. So it's either covered or not. And you could say, well, I just need 1 test case to cover that line. So in Oracle 12.2, there is a DBMS PLSQL coverage or code coverage that actually uses block coverage concept. So it identifies there are 2 code blocks here. One is the if, then return. The other one is the return. So there are 2 test cases again needed to cover that. However, you can also do the same functionality using an NDL function. And when you do that, again, that's just 1 test case to cover 100%. Doesn't mean that it actually is what it should, but yeah, 1 test case will do. And utPLSQL combines both profiler line coverage with block coverage from 12.2 to provide statement level coverage. What it actually means is when you look at our coverage report, you can see that the line was covered or line was not covered with tests. And it also indicates how many times the line was executed during the test run. But when you have a block covered line, or a line that has multiple statement in it, it will say the line is partly covered and 1 of 2 statements is covered in that line. And you can have a bird's eye view on your code coverage. So you have an aggregated view of the coverage for the whole test run. And we can also integrate with Sonar. So you can see your code coverage in Sonar if you're using Sonar. Now, what I showed was just how you can run your tests manually from SQL+, but that's not very convenient, especially if we're talking about DevOps and continuous integration. So utPLSQL provides you with a way to automate test execution in some way, to some extent. So when you think about continuous integration, it's just write the scripts, put them into version control, and then get this code from version control and deploy it and test. And then when those tests pass, you report out on them and everything is good. You promote to higher environment. If there are some problems, you probably stop the pipeline and say, well, we need to fix the problems before we promote. And then you repeat. So utPLSQL has utPLSQL client, which is Java-based utility that allows you to run your utPLSQL tests on an environment. You can specify what do you want to run. So it can be package names or schema names. You can also do mapping between your source code in your version control and the objects to get code coverage on your source code, really. And then you can provide multiple reports. So you saw the documentation reporter that I showed you during the demo, but you can also use coverage reporting and provide outputs in JUnit compatible way. So you can import those test results to some tools like Jenkins reporting or Sonar, etc. So utPLSQL allows you to integrate with all the standard CI/CD servers, including Oracle Developer Cloud or Flexagon, Travis, Jenkins, TeamCity. You can integrate test results and code coverage with Sonar. We have Maven plugin, command line utility. There is a plugin or extension for SQL Developer created by Philip Salvesberg. Toad has integrated utPLSQL already in version 13.2. And also, if you're using IntelliJ or DataGrip, utPLSQL is integrated with that out of the box. So like PLSQL developer is still on the way, waiting for someone to write a plugin for integration with that. But besides that, we're kind of covering quite a lot of tools already. Yeah, I think we're almost there. To summarize, write your tests to prevent bugs and avoid your company losing reputation or money, or you losing your job. Tests can easily become a documentation for your code, so they can actually help you and your colleagues understand the software and deliver software faster. Testing early is really beneficial for you. So if you can test first, that's great. If you can't, even testing right after you've implemented is better than testing 2 weeks after. You can group and organize your tests with utPLSQL using suites and suite path or contexts. I encourage you to leverage the automatic rollback, because then you don't need to worry about the data or leftover data after your test runs. You can report your test results using different reporters and look at code coverage reports using utPLSQL reporting capability. And the best way to go forward with testing is to have some form of automation, whether it's using Jenkins or any other orchestration tool to run your tests periodically or on every check-in of your code. So if you have any questions, now is the time, I guess. You can also reach us on utPLSQL Slack channel, or if you have any issues, report them on GitHub, or just tweet on Twitter at utPLSQL.
Great, thank you very much for that presentation. As you said, now is the time for questions. If anyone has any, then if you could pop them into the chat, or if you'd rather explain yourself verbally, then feel free to raise your hand. The option is on the participants panel, and I can unmute you from there. Whilst you have been talking, we have had one question come in, so I'm just going to put that forward to you. So the question is, if your procedure calls sequence next val, is this also isolated within the testing, or has the sequence value moved on?
So sequences do not fall under transaction control in Oracle. So unfortunately, utPLSQL is not capable of reverting or like isolating the sequence numbers. We would need to use totally different mechanisms, and that's far more complicated than using transaction control.
Okay, thank you for that. Not had any more questions come in yet. The downside of Zoom is I can't see if people are typing. So they might be typing, they might be hurrying to get a question in. I'm not too sure. So we'll just keep an eye and see if anyone has anything to ask there. You just never quite know. Just whilst we're waiting, just to recap, as I said at the start, this presentation is being recorded, and a recording will be uploaded to the UK OUG member library, so that you can watch it back or share it with your colleagues at another time, so that you can re-watch anything that you need to. Still not seeing any questions come in yet. So what I'm going to do is if I'm going to pop up a feedback poll for you all, which will appear on your screen any minute now. If you could just let us know there what you thought of today's webinar. It's helpful for us and it's also helpful for Jacek. So that should be appearing on your screens any moment now. It's not, it seems to be freezing on my screen. There we go. It's launched now. Not quite sure what happened there. Something on my end. So lovely. If you could fill that in before you leave us. Like I said, if you do have any more questions, then you can ask them now. It'd be great to, well, this is your time.
We still have 9 minutes to go, so
exactly.
feel free to ask any questions. Yeah. I'm really happy to answer any questions if you have some.
Yeah, I've got a comment rather than a question, and I just wanted to say thanks to you. It's enlightening to know this kind of testing is possible.
Yeah, it is possible, and actually, I know quite a few companies that excessively use it. Well, actually, we use it excessively in utPLSQL itself as well. So utPLSQL has around 900 tests for itself. So we really have high confidence releasing next versions without being worried about regression. Like across last 4 years, the functionality has grown significantly, and we wouldn't be able to release as frequently as we thought if we wouldn't have the test automation in place.
Okay, I've seen we've had a couple more questions pop up in the chat just now. So the first question is, what is the learning curve to integrate utPLSQL with TDD into a regular development cycle? This is, how hard is it to change into this I cannot pronounce that word. Paradigm.
Yeah, so I think changing to TDD is actually pretty hard. And the reason for that is because it's mental change. And in my experience, the more senior engineers you have, the harder it gets, because we're all creatures of habits, and everyone grows into their habits of how they would like to work when they are writing software. And it depends on how agile, and by agile, I don't mean like, sprints, but how agile you are really in your team. So how willing to change are you? So to be honest, I've worked for one company that was very heavily using TDD, and that was the only one in my life. I did see some attempts in many different companies to use that practice, but it's never really becoming a globally accepted paradigm. It's more like some engineers do it because they love it, or they really want it, or they use it sometimes. It's not like globally accepted standard, especially in databases.
Okay, we've got another question here. You mentioned about...
I see there is another question, so I'll just read it out loud. You mentioned about the documentation reporter. Does this create a separate HTML doc, or is it part of the test output? So the documentation reporter produces text report. And we actually don't have an HTML report for test results. What we have is an XML report that is JUnit, which is kind of a standard, and that JUnit test results can be interpreted by, let's say, Jenkins, and then it produces nice visuals. There are many tools that can transform JUnit into an HTML available.
Okay, we've got one more question here asking, how do you join the utPLSQL Slack channel?
I'm just pasting the Slack link now. So, sorry, wrong channel. This
Yeah,
is the Slack invite that you need to do.
okay. Are you
So if
happy?
you click on that, you can provide your email address, and then you can join utPLSQL's Slack channel.
Lovely. I can also send out that link in the post webinar email as well, if you'd like me to, so that others can join there. Great. Okay, yeah, I've just had the same thing. That link showing is no longer active, so you might need to get a new one. But if you want to send it to me,
okay.
If you want to send it to me afterwards,
I'll
and
do that. Sorry.
No worries. So I'll make sure that link is circulated to everybody after this webinar. That'll give you a bit of time to double check what you've got there. Okay, I don't think we've got any other questions coming in. So I think we will wrap it up there. So thank you again so much for your time presenting today. Very much appreciated. And I can see a few thank yous coming in the chat as well. So it looks like I'm speaking for a few people there. As I mentioned, the webinar's recorded. You'll get a link, and I'll also make sure that everyone gets the link to the Slack channel that we were just trying to share a moment ago. So thank you, everyone, and I hope you enjoy the rest of your afternoons, and hopefully we'll see you at another webinar again soon.
Thanks for joining.